In this video, we'll be reviewing chapter 3, which was relating the graphs of f prime, f, and f double prime, and it was also all the theorems. So we technically learned intermediate value theorem in chapter 1, but I went ahead and put it with these so all your theorems can be together. So we're going to first focus on the theorems, and then we'll kind of talk about f prime and f double prime. So intermediate value theorem, remember, like I just said, this is from chapter 1, so it has nothing to do with derivative. So if you're reading something and it looks like just f of x, or f of x or f of c has to equal a number, there's no prime anywhere, not in the conditions or the statement, it's probably IVT. Because all the other ones deal with derivatives. Well, extreme value theorem doesn't either. That one's kind of its own deal. But, so if f is continuous on the interval and the y value for the intervals don't equal, and then this is the most, to me, the most important one, in that some given y value falls in between the y values for the intervals. So this k is just representing a y value. It doesn't have to be the letter k. So it's just saying every y value that falls in between the y values for the intervals is guaranteed to have at least one x value, where f of x will equal that y value. That is the summary of what this is guaranteeing. So if it said, explain why there is at least one c in the intervals such that f of c will equal, let's say that's 5. Well, if 5 you'd have to use your function, you find f of a and f of b, and if 5 falls in between those two, then you know it's guaranteed by IVT. So the way you set up these sentences is you would say because, and then you would write your conditions. Because f is continuous. Now I will be honest with you, if you forgot the second condition, I don't think they would take off, but we'll go ahead and write it. F of a doesn't equal f of b. And now you can write it like this if that makes sense to you. If you want to put it in words, what that condition is, and k, which again, that's going to be a number. So I'm going to put a line there. Anything I put a line under, it means you're not going to put k, you're going to put actually whatever y value they're talking about in your problem. Falls in between f of a and f of b. Oh, here. By Rolle's theorem, by IVT, and then you just repeat whatever then statement. There is at least and 1 c blah 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 blah, which that should be in the problem. So you would just copy down what it states, what you're proving. Now, if it was a scenario where they wanted you to actually solve for that c, because there is at least one c, well then you just set f of x equal to k and solve for x, because c is an x value, right? There is at least one c, one x value, that if you plug it in the function, it gives that y value. So if it asks for c, you just set f of x equal to whatever that k value is and solve for x. Solve for x to no c. Now, they might not ask for that, though. They might just ask, is it guaranteed? And you would just write that sentence. Something this is used for a lot is to find zeros. Is there going to be a 0 in the interval? Because if you think about it, if 0 is your y value, well then if f of a is negative or positive, and let's say if f of a is positive and f of b is negative, well then 0 has to fall in the interval. So there has to be an x-intercept in that interval. And then vice versa, if this was negative and that was positive, 0 would fall in between there. So there has to be an x-intercept, right? Because an x-intercept, the y value is 0. So it can be used to find zeros. I'm going to cross this off. It doesn't really make sense. I'm going to say if f of a and f of b One is positive and one negative. So that's just a common use of this theorem. The next theorem is extreme value theorem. We don't use this one too much, but it's just saying if f is continuous on an interval, then on that interval there has to be a max and a min. So what that actually, how we use this theorem is when we find absolute max and min on an interval, right? And we kind of talked about this down here, but let's go ahead and write it up here. So to find an absolute max or min on an oops, I don't know what I was writing there. Remember, you find critical points, find critical numbers, which, what is a critical number? I'm not going to write it because I think we put it down here, didn't we? Or we'll put it down here, but it's when f prime equals 0 or undefined. That's your critical numbers. So you find your critical numbers and then you test critical numbers and endpoints into original, right? So you can write original or f of x, and you just see the highest y value is the absolute max on the interval, the lowest y value is the absolute min. So absolute max and mins can only occur at critical numbers or endpoints, and that ties to that extreme value theorem. But for sure though, there is going to be a max or min, because if there's no critical numbers, then it's going to be the endpoints. So the next two kind of go together. Rolle's theorem is if your function is continuous on your interval, differentiable on your interval, and this is what makes Rolle's theorem special. I was going to try to switch colors in case anything gets close together. F of A needs to equal f of B, right? So if those three things are true, then there is at least one number C, which again is an x value. C is representing some x value that falls in your interval where the derivative will equal 0. Which, another way to think, where does the derivative equal 0 at relative mins and maxes? So it's just guaranteeing that your interval is going to have a relative min or max. You can add the word relative there if you would like. So something to keep in mind on these is sometimes it just says f is differentiable, but to be differentiable you have to be continuous. So just keep in mind, if they tell you differentiable, you automatically know it's also continuous. So again, the setup you would use if it was just saying, is there some C where in AB such that f prime equals 0, you would do this same setup. We'll write it out again, but for Rolle's. So how you start is you say because, and now you write your conditions. F is continuous, f is differentiable, and f of A equals f of B, comma, by Rolle's theorem. And then you would just repeat this sentence, whatever your question's asking you to prove, there is at least at one C, however it words it, but it should end such that f prime of C equals 0, f prime of x equals 0, however your question is worded. So you should just be copying down the question for that ending. Now if it asks you to actually solve for C, which again, it's not going to always ask you to do that, but if it does ask you to solve for C, you would just set the derivative function equal to 0 and solve for x. Set f prime of x equal to 0 and solve for x. Okay, so the mean value theorem is similar. but the only conditions is that it's continuous and differentiable in the intervals. So you don't need that f of a to equal f of b. And for this one, what it does is it guarantees there's some c in the interval where the f prime of c equals this, which what is that? You should recognize that format. That's the average rate of change. F of b minus f of a over b minus a. So it's guaranteeing that somewhere in your interval the instantaneous rate of change needs to equal the average rate of change, right? Derivative is instantaneous rate of change. This is average rate of change, which if you watch the chapter 2 video, we were saying instantaneous rate of change is slope of the tangent line, and average rate of change is the slope of the secant line. So what that would look like if you wanted to visualize it is for any function, it could be quadratic or just increasing, decreasing. If this is a and we'll say this is b and you have your 2 points, if you draw your secant line that connects them, that average rate of change is f of b minus f of a over b minus a. There's going to be some tangent line where the slopes are the same, where it's going to be parallel. So it's always hard for me to just freehand this to figure out where, but somewhere between here you can draw a tangent line that's going to be parallel. It looks like, no, that would be, that's almost, it looks like it might be like right there. No, because that's going to be, you have to be really close to the top because that's almost horizontal. I don't know if y'all get what I'm saying. So this C value right here, where that tangent line is parallel to that secant line. But how they normally ask it is the same as the top, how we've been writing the top, is you would, so on this one though, be careful because it's not going to, that's going to be some number. So anytime you just see f prime of x or f prime of c equals a number, oops, I was going to write c again, I don't know why. You need to first show f of b minus f of a over b minus a equals that number. Okay, so notice that's not using derivative, that's using the original. And then if it does equal that number, then we can write that sentence we've been writing, because f is continuous and differentiable on the, you could say on the interval, or if it's continuous and differentiable everywhere, you could just write that. But like if there was a sharp turn but it wasn't in the interval, that would be okay. It just has to be continuous and differentiable on the interval. By MVT there exists, and again you just copy however it words it, dot dot dot, where f prime equals that number. And you don't need to say because it's the average rate of change if you show this somewhere on your paper for that problem. So if it did happen, normally free responses are like that set up, but if they did say what number c, how would you solve for that c? Again, it's an x value, so you're solving for x. So you still have to first find, I'm going to say, to solve for c, because I think there's a question on your AP practice. We have to do this. You first find your average rate of change, your f of b minus f of a over b minus a, and then your second step is you set the derivative f prime of x equal to whatever that number is and solve for x. I'm going to just put equals number. I'm going to say that equals number and solve for x. Okay, so hopefully that makes sense. I think what I'm going to do is stop this video here because it's all theorems, and then we'll talk about these boxes and the back on relating derivative graphs video.